This video deals with the optimal price setting of a firm if the objective of the firm is to maximize its revenue. The revenue of a firm is given by the quantity that the firm can sell times the price that it can charge. So that's the total turnover of the firm. And sometimes in economics we are interested in the situation when a firm wants to maximize this revenue. More often we maximize the profits, but sometimes we may also be interested in revenue maximization. Now the problem that occurs in this situation, if you assume that the firm can set the price in this context, is that if the firm sets a higher price, so if P goes up, then this would lead to a reduction in demand Q. So there are two opposing effects. And the question is, which of these effects dominates and when does the firm reach the optimal price level for maximizing revenue? And as we will see next, this depends crucially on the price elasticity of demand that the firm faces. To see this, we go back to the description of the price elasticity of demand in case of a linear demand curve. So you already know from the corresponding chapter that the price elasticity of demand changes along a linear demand curve, where the elasticity is high in this area when the price is high and the quantity is low, because a price change in absolute terms is a comparatively small percentage change, while a certain given change in the quantity is a comparatively large percentage change because the level of quantity is low and the level of the prices is high. So in this area demand would be elastic, and here down in this area demand would be inelastic because here the quantity is comparatively high and the price is comparatively low. So a given change in the price is a small change in percentage terms, and it's a large change in percentage terms, and a given change in quantity is a small change in percentage terms. And somewhere the price elasticity of demand is equal to -1. So that separates the two areas of the curve. Now it's already clear in intuitive terms that something here will happen at the point where the demand curve switches from being elastic to inelastic. So at this point where we have a unit elastic demand curve. And what is this? Well, let's draw the diagram again in a different way. Now the demand curve is just dotted. We don't have all the descriptions here to get rid of some of the notation. And then there is a red vertical line at the point where the price elasticity of demand is equal to -1. So this red line now separates the area in the graph where the demand curve is elastic and where it is inelastic. Now we remember the definition of revenue. That's the quantity times the price. So if we draw in this diagram here the revenue curve, then we would get a situation where the revenue curve has the peak at the red vertical line where the price elasticity of demand is -1. Why? Because if we are to the left of this vertical line, demand is elastic. That would mean that if we move along the demand curve and reduce the price, then quantity would increase in percentage terms by even more. So to compensate the reduction in the price, the effect of the reduction in the price on the revenue, and revenue would raise even because the quantity increases by more than the price decreases. So that's to the left of this vertical red line. To the right of the vertical red line, however, we have the opposite case. So here, if we reduce the price further, however, demand is inelastic there, that means that the reduction in the price reduces revenue and the quantity does not increase by so much that it could compensate for this effect. So here, if we decrease the price further, the revenue would fall. And obviously now the revenue would be at its maximum if we are at the point where the price elasticity of demand is -1, because exactly at this point there is no change in the revenue when I reduce the price, because then quantity increases by the same percentage as we reduce the price, and that would mean that revenue, P times Q, stays the same. So revenue would stay flat. And the nice thing is here, but this is just a side remark, that you already see again the connection to the derivative. So if you want to maximize revenue, you would take the derivative of revenue with respect to the price and set it equal to 0. And why do you do that? Because you set it equal to 0 because you want to get the point at the curve where the slope is 0, so that the price change does not change revenue anymore. And that would be exactly this point here, where the slope of the revenue curve is 0, so where we are at the maximum point. And that's the reason why, if you want to maximize a function, you would do so in analysis by taking the derivative of this function and setting it equal to 0. So we could draw this also in the diagram as this horizontal curve here that is a tangent to the revenue curve exactly at the point where the price elasticity of demand is equal to -1. And at that point we see the derivative of revenue with respect to price P would be equal to 0, because the slope here would be equal to 0, and it allows us to identify the maximum of the revenue, which we already know from our geometric argument before, must be at the point where the price elasticity of demand is equal to -1. So we can summarize: if the demand is elastic, a price reduction would raise the revenue. If demand is inelastic, a price reduction would reduce the revenue. And that means that exactly at the point where the demand is unit elastic, a marginal price change leaves the revenue unchanged, and that is the point where the corresponding price and quantity level would maximize revenue. Thank you very much for watching the video, and I hope you found it interesting and useful. For more videos on economic content, please visit my channel that you find here to the left. And to the right, you see the next video in the series at the top, and at the bottom, you see the whole lecture in the form of a playlist.